Okay, welcome back. This is topic number 3 in our unit on organic chemistry. Our topic for today is branched hydrocarbons. So we've been talking about these long, straight-chained hydrocarbons, but there are some hydrocarbons like that actually have smaller little chains of hydrocarbons that are dangling off of them. Okay, now the longest chain in the molecule is known as the parent chain, and so then the little thing that's dangling off of it is known as a branch. Another important term for today's lesson is isomer. The word iso means there's something that's the same. So they actually have the same molecular formula, the same number of C's, same number of H's, okay? But the thing that's different is the way that they're put together. They have different structures or different arrangements. Okay, so this is one example of a branched hydrocarbon. Take a moment to copy down what you see. It's a 6-carbon parent chain. Then off of that parent chain, I do have another hydrocarbon that is branching off of it. Okay, and so in my diagram, I have highlighted the parent chain using a green dashed box. I was able to find the parent chain because it's the longest continuous chain of carbon. I then numbered all of those carbons, all right? And then the next thing that I did is I took a different color and I circled the branch that comes off of the parent. There may be one branch. When we get more advanced, there might be more than one branch. But for now, we'll stick with this. So the way that we name this is actually working a little bit backwards. Okay, so instead of naming it from left to right, we're actually going to start over here. Since this is a 6-carbon single bonded chain, we're going to call that hexane. The hexane has a little piece that's dangling off of it that has just one carbon in it, but it's not a CH4. It's a C with 3 H's, and so that branch actually has a different ending. It's not ANE, it's not ENE, it's not YNE. It's just YL. So this one carbon meth becomes methyl. So we have methylhexane. And then we need to be able to communicate to others where that methyl is attached to the parent chain. And so your numbering should be such that the lowest number possible is assigned to your branch. So here I started numbering on the left. I went from left to right because my branch was closer to the left side. So we would call this 2-methylhexane, which means that we have a branch on carbon 2. The branch is 1 carbon in length, and the parent chain is 6 carbons long, all single bonded together. Take a moment, draw it, and we'll move on to the next slide when you're ready. Okay, now we're going to be sort of almost playing with Legos. These isomers, we're going to start with the same molecular formula. I'm going to be working with 5 C's and 12 H's all the way through. I've started with a skeleton or like a backbone of the carbon. So in our first example, we're going to try, what is it called when it's just 5 carbons in a row? Then I'm going to pop one of the carbons off the end and stick it on one of the interior carbons. So you cannot have a branch of carbon on the end. It's impossible. It ends up just being sort of bent. It's like if we swung that this way. It's not actually a branch, it's just a bent version of the molecule. So I now have 4 carbons in a straight chain with a 1-carbon branch that comes off of it. I could take that a step further and I could actually try a 3-carbon chain with a branch up above in the middle and a branch down below in the middle. Let's add some hydrogens to make sure we have enough. I'm just going to use the red bond to indicate an understood hydrogen. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in all of these, we still have C5H12, but you'll notice because they all have different structures, they should all be named something different. This single bonded chain is known as pentane. Okay, now this next one is an example of what we've been talking about today. The parent chain, the longest chain that comes together, 4 carbons in a row. So we will call that butane because it's all single bonded together. Now we have this one little branch. It's 1 carbon in length, so that's called methyl. Then, because it's closer to the left-hand side, we call this 1, 2, 3, 4. So this is 2-methyl-butane. Now, this next one is probably the most complicated we're going to do all day. Now, I'm going to highlight my parent chain because the longest chain that I can find is 3 carbons in length. So that parent chain right there is called propane. Now, I have a methyl branch that's up here. We've seen that before, we just did it in this example. But here's the curveball. There's another methyl down at the bottom. So I have 2 branches that are exactly the same thing. When that happens, we're going to use a prefix with the branch name. So it's methyl, just like before, but there are 2 of them. So we're going to use the prefix di. Okay, so we got dimethylpropane. The last thing we need to do is to communicate to the other people, where are those branches located? I got carbon 1, carbon 2, carbon 3. My carbon branch that goes up is on carbon 2. My carbon branch that goes down is also on carbon 2. So there you go, 2,2-dimethylpropane. Let's move on and take a look at something that has a longer branch. Okay. Start by highlighting your parent chain. Obviously, you're going to need to have this in your notes, so take a moment, copy it down. Then when you're ready, start the video up again. I have 1, 2, 3, 4, 5, 6 carbons in a row. We call that hexane. Okay? Now, your branch. This is 1 branch that's coming off of one side and it's continuous. And in this 1 branch, I actually have 2 carbons now. So this branch is not a methyl, it's not a dimethyl. This is what we call 2 carbons ethyl. So ethyl, it is an ethyl hexane. The last step, we got to put a number on it. On which carbon is it attached? 1, 2, 3. Okay, 3-ethylhexane is the name of that monster right there. Let's move on a little bit more. Okay, I think you're ready. Try these. In this column over here, I've given you some kind of complicated structures. I want you to name them using words and numbers. We got this guy right here, and you got this guy right here with a couple branches. That one's tricky. Okay, then I want you to draw. I want you to take this long, complicated looking thing, I want you to translate it into a structure that looks kind of like this. Then I want you to do exactly the same thing, but I want you to draw me a 4-ethylnonane. Okay? So try those 4 problems, write them down. If you have any questions, be sure to jot those down. Bring it back with you to class tomorrow. Good luck.